Hello everyone, welcome to my channel Mathenthusiasm. This video is day 17 of the 30-day challenge. It is all about integration by parts. Today I'm going to use two different approaches to work out this integral. The answers by the two methods look different to each other. However, I will show you that they're actually the same. Let's check it out. Integrate x sine x cosine x dx. This integral is really special because the integrand is a product of three terms. It's kind of rare in many cases. For the first method, we can change it into a product of two terms only. By how? Let's make use of the double angle formula. Sine 2x is equal to 2 sine x cosine x. So sine x cosine x is equal to 1 over 2 sine 2x. We put this result into the integrand like this. Now, it is a product of two terms, x and sine 2x, instead of three terms. At this point, we'll have to decide which term to be absorbed into the differential. Because x is algebraic function a, sine 2x is trigonometric function t. By the last rule, a is in front of t. So a is u and t is dv. In other words, we'll have to absorb sine 2x. That is to integrate it. Therefore, the integral is equal to negative 1 over 2 times 1 over 2 times integrate x d bracket cosine 2x. Comparing it with the formula of integration by parts, u is equal to x and v is equal to cosine 2x. In the next step, we'll have the constant negative 1 over 4. Inside the bracket, the first term is the product x times cosine 2x. The second term is the integral by swapping u and v, which is integrate cosine 2x dx. This can be evaluated easily. It is equal to 1 over 2 times sine 2x. Let's take out this 1 over 2. Therefore, the answer of method 1 is equal to 1 over 8 times bracket sine 2x minus 2x cosine 2x plus c. Here, we have put the negative sign inside the bracket, so the two terms are interchanged. Then, what is the second way to solve this problem? For method 2, we're going to absorb one term right away. Let's focus on the term cosine x. If we absorb it into the differential, that is to integrate it, then it is changed to integrate x sine x d bracket sine x. Now, we look at the part sine x d bracket sine x. This form is just like t dt. If we absorb for the second time, then it is equal to 1 over 2 times the bracket t squared. Likewise, we have sine x d bracket sine x is equal to 1 over 2 d bracket sine square x. We put this result into the integral. You see, it is already in the form of integration by parts. U is equal to x, and v is equal to sine square x. The first term is the product x times sine square x. The second term is the integral by swapping u and v, which is integrate sine square x dx. Actually, we have come across the second term in the video on day 14. It is by double angle formula. You may check the link above for more details. Here, we just state the result, which is 1 over 2 times bracket x minus 1 over 2 sine 2x. Let's remove all the brackets. Then the answer is equal to 1 over 2 times x sine square x minus 1 over 4x plus 1 over 8 sine 2x plus c. Now, let's compare the two answers. If we put them together, you can see that they are not exactly the same at the beginning. However, we can use some tricks to show that they are equal. Let's take a closer look to the terms. Both expressions have 1 over 8 sine 2x. Therefore, we combine the first two terms in the second answer. We take out the common factor 1 over 4x. Inside the bracket, we have 2 sine square x minus 1. Indeed, this term can be simplified. Again, we make use of the double angle formula. This bracket is equal to negative cosine 2x. At this moment, we take out the factor 1 over 8. Then we get 1 over 8 times bracket sine 2x minus 2x cosine 2x plus c. This is exactly the answer from method 1. In next video, we shall look at this challenging integral of trigonometric functions. Check out the link of day 18 on the screen.